All right, so this assignment was page 405, number 29, 33, 35, and 37. And so in this assignment, we're focusing on electronegativity and using that to tell us about the kind of bonding that's going on. In our POGL last week, we learned that there are different types of bonds: ionic, metallic, and covalent. And all of those types of bonding are related to the differences in electronegativity between the elements that are bonding together. So on this particular problem, when it says to predict a bond which is most polar, that is asking us to find out the one that's got the biggest difference in electronegativity. You guys did this in your POGL, so hopefully it's pretty easy to remember. But I can't use the actual numbers here. So when it says without using figure 8.13, that means you need to use the periodic trend. Now the trend for electronegativity is that it increases going up a group and increases going across the periodic table. So if I'm picking two elements here that have the biggest difference in electronegativity, I'm looking at, well, all of these are bonded with fluorine. So I'm guessing which one is the furthest down their group. We got carbon, silicon, and germanium. So all three of these are right there. And we're trying to find the most polar one that's bonding with fluorine. So if we look at that periodic trend, I think it's pretty obvious that the biggest difference in electronegativity would be between germanium and fluorine. So the most polar bond here would be Ge and F. For the next one, our two choices are PCl and SCl. So again, Cl is right here, and we're choosing between these. Again, we're picking the biggest difference in electronegativity. So since phosphorus is further to the left than sulfur is, then the one that I think is going to be the most polar would be the PCl bond. It's got a bigger difference in electronegativity than sulfur and chlorine would. For part C, we're choosing, now this one's kind of a little bit different. All of them have sulfur in them, which is right here, and we're choosing between SF, SCl, and SBr. Again, I think the bigger difference in electronegativity here is going to be between S and F. Fluorine is the most electronegative element on the periodic table, so that's going to have the biggest difference. S and Cl are going to be pretty close to each other, as is S and Br. And then last one, part D, we have TiCl, SiCl, and we've got GeCl. So here's my Cl right here. We're choosing between titanium. Where's titanium? All the way over here. Silicon, and then germanium. And I think you can see that because the titanium's all the way out here and the chlorine's over there, they're going to have the biggest difference in electronegativity. So Ti and Cl would be the most polar. All right, question 33 says, which of the following incorrectly shows the bond polarity? Show the correct bond polarity for those that are incorrect. So you guys see these little symbols here, these little deltas. So let me erase this so you can kind of see them. So you have a delta positive and a delta negative. Now we put the delta negative symbol on the most electronegative atom. And then the delta positive goes on the least electronegative atom. So we're basically going to use our periodic trend knowledge and we're going to figure out, did they place these symbols on the right elements? And so for A, we have the delta positive on the hydrogen and the delta negative on the fluorine. Remember, hydrogen's over here, fluorine's over there. Remember, our periodic trend for electronegativity is it increases going up a group and increases going across the periodic table. And so I think they got this one correct. So I'm going to put a little check mark. I think A looks good. For B, they gave us the delta positive symbol on chlorine and then the delta negative symbol on the iodine. So both of those are halogens. There's chlorine, there's iodine. So if I'm following the periodic trend, chlorine should be more electronegative than iodine. So they did make a mistake on this. So to correct it, we're going to rewrite it. Chlorine with that delta negative symbol, and then the iodine will change to a delta positive. For C, we're choosing between silicon and sulfur. They said that the silicon is delta positive, which is right here, and the sulfur they gave is the delta negative. And if you look at the periodic trend, that fits. The electronegative element here should be sulfur, and the less is silicon. So it looks like they got the symbols correct. For part D, we have bromine and bromine. Well, these are both the same element. So if they're both the same element, they have the exact same electronegativity. So there shouldn't even be any delta positives or negatives. So I would just leave them. Okay, they're going to be sharing electrons equally. Lastly, we're choosing between oxygen and phosphorus. So the oxygen is right here, phosphorus is over here. If we're following our periodic trends, oxygen should be more electronegative than phosphorus. So they got this one wrong. The oxygen should have the delta negative symbol, and the phosphorus should have the delta positive. All right, so 35 says, predict the type of bond, ionic covalent or polar covalent, one would expect to form between the following pairs of elements. Now, you should have done the POGL already at this point. So if we're looking at the POGL, ionic has a very big difference in electronegativity. Covalent has a medium difference in electronegativity. And then metallic has very little. But that's not what they're asking us to choose between. See, we're choosing between ionic, covalent. A little glitchy there. All right, so again, we are choosing between ionic, covalent, and polar covalent. Ionic would be a huge difference in electronegativity, and we've started seeing this year that ionic is between a metal and a nonmetal. Covalent is between nonmetals, but they do not have a difference in electronegativity. And then polar covalent has a large difference in electronegativity, but they're still both nonmetals. So we follow that logic. We got rubidium and we got chlorine. Rubidium's a metal, chlorine's a nonmetal. They're on opposite sides of the periodic table, so there's going to be a very large difference in electronegativity here. I think that's going to be ionic. Now B, we got sulfur and sulfur. Anytime you have two nonmetals that are the exact same element right next to each other, this is going to be covalent. Not polar covalent, because they do not have a difference in electronegativity. Now C, we've got carbon and fluorine. Now carbon and fluorine are right here. They're both nonmetals, and there is a difference in their electronegativity. Remember, electronegativity increases across, increases up. So I think this is going to be polar covalent. They're going to share electrons, but not equally. D, we got barium and sulfur. Now barium is a metal. Sulfur is a nonmetal. They're very far apart from each other on the periodic table, so I think this is going to be ionic. And then E, we've got nitrogen and phosphorus. Both nonmetals, but they're not the same nonmetal. So I think you can see where I'm going with this. There's a difference in electronegativity there. Not as much as ionic, but there is a difference. And since they're both nonmetals, we're going to predict that this is polar covalent. And lastly, we got boron and hydrogen. This one's a little bit tricky. Boron's right here, hydrogen's here. They're actually not that far apart from each other when you really think about it. And so I would predict that this is going to be polar covalent still. Now boron is a metalloid, not a full metal, and hydrogen's a nonmetal. So if you have a metalloid with a nonmetal, it has the ability to bond as a covalent bond and not ionic. All right, last problem. So we got 37. It says hydrogen has an electronegativity value between boron and carbon and identical to phosphorus. With this in mind, rank the following bonds in order of decreasing polarity. So decreasing polarity means we're going to put the biggest difference in electronegativity first, and we're going to end with the least. So if we're having hydrogen, it looks like we've got fluorine in here. We've got oxygen is another one we're going to compare. Nitrogen, carbon, and boron. Oh, not boron. Just kidding. That was a joke. Phosphorus is what they said. Now they did say phosphorus and hydrogen have the exact same value, so I'm actually going to put that last. Okay, and we're going decreasing polarity. So I'm going to start with that one actually and go up from there. So the next one I think is going to be the least difference. Remember, we have electronegativity increasing across the periodic table. So I think C and H are going to be next, followed by N and H, then O and H, and then lastly, the most polar bond would be the biggest difference in electronegativity, and that would be between F and H. So we're going to continue to review this more, but if you guys have any questions, again, always come by and see me whenever you guys have questions.